Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on structure and bonding, and we're going to be looking at the giant atomic structures. So previously we looked at the molecular structures. We had said that the covalent bonds forms two structures, which is molecular structures and covalent structures. So we are going to look at giant covalent structures, or also known as giant atomic structures. And then we're also going to look at some few questions. So for giant covalent structures or giant atomic structures, these are atoms that are linked throughout the whole structure by very strong covalent bonds from one atom to the next. It results in an infinite number of atoms which are covalently bonded together. So the pattern occurs repeatedly throughout the structure, leading to a giant. So that is where the word giant comes from, leading to a giant of atoms or covalently bonded. So we have different compounds that are under the giant atomic structures. One of them is diamond. So diamond is an allotrope of carbon. So this is going also to be repeated in carbon and its compounds in form 2. Allotropes are different crystalline forms of the same element in the same physical state. And diamond is an example. We are going to see another example in a minute. So in diamond, the carbon atom is molded to 4 other carbon atoms by strong covalent bonds. So if you look at carbon is atomic number 6, so it has a configuration of 2.4. So you can see the 4 electrons in the outermost shell can be used to share with other 4 carbon atoms. So that's why it says it can bond with 4 other carbon atoms to produce strong, very strong covalent bonds. So the carbon atoms in diamond are bonded in an octahedral pattern, as you can see below here, which repeats itself in all directions, resulting to a giant atomic structure. So you can see how the diamond is repeated completely as you go down, and it forms a very giant atomic structure. Since each atom is bonded to 4 other, all the 4 valence electrons are reused in body. So we do not have any delocalized electron. You're going to see this why one of the properties of diamond is as it is. So diamond is one of the hardest substances. And why is it hard? Because all the atoms are covalently bonded together and they are closely packed. So you see there is a strength of the bonding together and the packing together. So some properties of diamond is that they have high melting points and boiling points. And this high melting point and boiling point can be attested to the strong covalent bonds throughout the structure. These covalent bonds throughout the structure require a lot of heat to break. Then they also are insoluble in water because they are non-polar. So diamond does not dissolve in water. Water is polar. So we said non-polar and polar substances cannot mix because there is no dissociation of ions that can attract each other. And then diamond does not conduct heat or electricity. The reason why it doesn't is because diamond is bonded by 4 carbon atoms, but only all the 4 electrons are used in body, all of them. So we do not have any delocalized electron. So if they are not delocalized electrons, then conductivity is not going to happen. Then diamond is also known as one of the hardest substances known. We said it's hard because the atoms are compacted or they are arranged in a continuous octahedral pattern with covalent bonds throughout the structure, which is very hard to break. Next, we look at graphite. Graphite is also an allotrope of carbon. It is bonded by three carbon atoms. So every one carbon atom is bonded by three other carbon atoms to form strong bonds. So you'll notice in graphite, you're not using all the four electrons in the outermost shell, you're only using three of them. So each single carbon atom is only bonded to three other of the four valence electrons are used in bonding. So we have one delocalized electron. The carbon atoms in graphite are usually bonded in hexagonal layers, which are joined together by weak van der Waals forces. So you can see from the diagram the weak van der Waals forces in the atoms, in the arrangement of the atoms. These are the weak van der Waals forces. And then the presence of the weak van der Waals forces explains why it's slippery, because it keeps sliding over each other. So some of the properties of graphite is that it has high melting point and boiling point. This is because its structure is bordered by strong covalent bonds. So these strong covalent bonds require a lot of energy. Although we said that in the arrangement of the atoms there are van der Waals forces between the layers, they do not contribute to the high temperature. The high temperature is contributed by the strong covalent bonds. And then the graphite is also insoluble in water because it is also nonpolar. We said nonpolar do not dissolve in nonpolar. Polar dissolves in polar because of the dissociation of ions and the interaction of the ions as well. It is a good conductor of heat and electricity, which is contrary to diamond, and this is because only three of its valence electrons are used in bonding, which leads in the presence of a delocalized electron. So that's why it can conduct heat and electricity. And then it is soft and slippery. We said it is soft and slippery because the carbon atoms in the graphite are bonded in hexagonal layers, which are joined each other by weak van der Waals forces. And these van der Waals forces causes it to slide over each other when pressed. So that is the reason why it is soft and slippery. So let's look at a few questions in regards to what we have discussed. Diamond and graphite are allotropes of carbon. In terms of structure and bonding, explain why diamond is used to drill through hard rocks. Basically, you're being asked why diamond is hard. Diamond is hard because the carbon atoms are bonded by strong covalent bond, and they are arranged in a regular compacted octahedral pattern. It's compacted. That's the reason why you can't separate them. Graphite is used as a lubricant. We said that the layers of graphite are bonded by weak van der Waals forces which slide over each other when pressed. So that is the reason why graphite is used as a lubricant. The following diagrams show the structure of two allotropes of carbon. Study it and answer the questions that follow. So we can see allotrope M and N. So we know that allotrope M from the structure is graphite and allotrope N is diamond. So name allotrope M and N, we have done that. Give one use of N. So one use of diamond, it is used to make drilling bits or equipment. So you can go ahead and tell why. It's because the carbon atoms are bonded by strong covalent bonds and are packed in a regular octahedral pattern. It can also be used to make ornaments because it is shiny. And then if we look at allotrope M is used to make pencil leads because it slides over each other, and it's also used as an electrode because it can conduct electricity. So this answers also the next question, which allotrope conducts electricity? So we said it is allotrope M because only 3 of the 4 valence electrons are used in bonding. So there is one delocalized electron that is used to conduct electricity. So I hope you have been able to see. So remember that apart from diamond and graphite, we have another uh, also a giant atomic structure called silicon 4 oxide. This is silicon bonded to oxygen in a regular pattern, also with strong covalent bonds that we haven't mentioned. We don't go into so much details with silicon 4 oxide as compared to later on in the when you get to campus, but that is also another giant atomic structure. So I hope you have been able to see their properties and can identify those properties well. See you in the next lesson.